Hello and welcome back. This is Paolo, your host. This is Conversation in Artificial Intelligence. And I know that I always say it, that this is a very, very interesting episode, but this one is going to be an exceptionally interesting episode. And the reason is that we're going to cover machine learning from a very, very interesting perspective. And it's basically the perspective of how machine learning and artificial intelligence is being applied to traditional company in a way that is, if you like, very pioneering, applying really the cutting edge machine learning to the most traditional companies. With me today, we have the founder of Infineon ML, the former CEO and founder of Automated Insight, Robbie Allen, who is also a professor at the University of North Carolina. Hello, Robbie, how are you today?
Doing great. Thanks for having me. And actually, I'm going to agree with you. I think this is going to be a special episode.
I'd like to start off saying, how did you stumble upon artificial intelligence? It was, was there a particular episode that made you getting into it?
No, not really. I've always been interested in automating things. So my undergraduate degree was in computer science. And I got exposed to programming pretty early on. Then I did my graduate work at MIT, and this was in my undergrad was in the mid 90s. My graduate work is in the early 2000s. This was still before artificial intelligence and machine learning really was all that interesting, frankly. But I was still wanting to automate things, right? And so I worked at some big companies, developing software. And then eventually in 2010, I decided to start my own company, Automated Insights, trying to automate the creation of text. And that was kind of how that got started. Again, really before the machine learning wave took off. And then now for this new company, we fully embrace machine learning, and we have a pretty amazing team of machine learning experts that are doing some really great things.
For our audience here, Automated Insights, in my opinion, is doing something extremely, extremely interesting, which is basically creating media articles automatically, like artificially. How did the idea come up, and how good did the technology get over the time?
So it dates back to my love of UNC basketball. So I'm a big University of North Carolina basketball fan. You mentioned I'm an adjunct professor at the business school there. Anyway, I've been a lifelong basketball fan. And in fact, I started the first blog dedicated to UNC basketball back in like the 2002 timeframe. And so I started writing a bunch of recaps after every basketball game. And I come to realize that those were pretty formulaic. And eventually, because I like to automate things, I thought, well, if I had access to the data, it seems like I could automate the recap generation process. And so that was kind of where the early idea behind Automated Insights came from, was this notion that I could automate sports recaps.
Where did he get in terms of, the technology quality? I read some of your articles where you said at the beginning there was this belief that people didn't believe that this was even possible. So basically, we're talking about an automated journalist. But then you said that towards the end, before you left, you got to a point where people expected more. Can you tell us a little bit this kind of a customer journey where they don't believe first and then they want more?
You go to a company and say, yeah, we can take your data and automatically create a story about the data that sounds as if a person wrote it. Well, that's almost like saying that I'm going to, get them on a rocket and take them to the moon and back, right? They just looked at me like they couldn't quite understand it. It didn't make sense. And that, we'd have to show them lots of examples of it. And so, that was just kind of a difficult thing to educate the market on. But then after, many years of autonomous cars and artificial intelligence, press releases, and every company now is a machine learning company, we'd have conversations and companies would say, oh, it just generates stories automatically. Well, can it also process my payroll and, help me hire and fire and all these other, they think that artificial intelligence should be able to do everything now. And so in a very short amount of time, we went from a complete disbelief that you can do anything with it to a complete sort of exaggeration of what people think it can do.
One of the things that struck me when we were talking about doing this interview is that eventually, even though you have created this company and then you created another company, you are actually in the process of writing a book. So not sure where you find the time to do all of these many things, but you're writing this book that is called Machine Learning in Practice. And I'm always very, very fascinated by the word in practice, because there is tons of theory out there, but there is very little about the practice. So first of all, what made you writing this book, and where did you find the time to do it?
Yeah, so my company, InfiniML, we really provide the people, process, and technology to help automate enterprise business challenges with data science. And so really what we do is help companies apply machine learning inside of their companies. And what we found was, even though there are a lack of data scientists, there is plenty of educational material on the web, and plenty of resources. And I've even written about many of these on my Medium blog, on where to find information on how to do data science and machine learning. Not that it's that easy, it still requires a fair amount of study, but there's at least those resources out there. What we found was lacking was, when we go inside of some of these Fortune 500 companies, the managers and executives and project managers, they really didn't have the tools or resources to understand how to apply machine learning. And in fact, it is different than traditional software development. And so we thought, well, this would actually be a good chance for us to write a book around this whole process of deploying machine learning inside of a company, or adapting it to fit your product or help automate processes. And therefore, we'll be sort of the company that wrote the book on it, and it'd be a great way for us to help educate our clients as we work with them.
So one of the things that we find this book, as you said, is like ways of educating managers and people that are not necessarily on doing the data scientists, but they're responsible for the hand-to-hand delivery. And one of the things that is really interesting to me is seeing that you have some of the chapters that are about evaluating potential machine learning projects. So how does a manager evaluate a potential machine learning project, in your opinion?
There's a number of factors that go into what make a good machine learning project. The first and foremost is accessibility of the data. And so you can't have machine learning without a good data set. And generally, and this is kind of roughly speaking, but the more data that you have and the more high quality data that you have, the better opportunity you'll have for success with a machine learning project. And so you have to have the data first and foremost. Others, you have to have, ideally a business challenge that's worth solving. Oftentimes companies get stuck in, hey, let's do something with machine learning because everybody's doing something with machine learning, and they lose sight of the fact that it really needs to ultimately have a business impact. And that's what my company, InfiniML, is focused on. We don't do science experiments or projects in which there's not a real business value that could be generated from it. And so really you have to apply, where do you have data, where do you have a problem that you can solve, and then where do you have sort of an organization that can ultimately embrace and support the deployment of this. And again, there's a whole set of things that probably you'll have to read the book when it comes out later this year to see the number of things that are involved with deploying machine learning. Again, it's not like traditional software.
So if you had to give a snapshot of what you conceive or define as, it's not like a traditional software. I totally agree with you, and I've also written and done videos on this topic, but I'd like to hear from you. What do you think is different than traditional software development, and how do managers can understand this difference?
You can almost answer any machine learning question, partially answer it with something related to data. So in terms of stakeholders for projects, in traditional software development projects, in many cases, the data is not sort of a key piece of the project in terms of, its existence is going to make the whole operation work. Whereas that's absolutely the case with machine learning. So first you have to figure out, who are the stakeholders when it comes to the data, and ultimately, who's going to own that process for getting data into your machine learning models and ultimately using the results coming out. The other big thing that's different is typically with traditional software, when you deploy a piece of software into a production environment, you're kind of done. I mean, you still have to maybe, monitor and test and keep an eye on it. But with machine learning, you really are just getting started once you've deployed a model into production. It's not that you're almost done. In fact, you're just getting started. You have to monitor the results coming out of the model. You have to keep an eye on to make sure that the results are similar to what you trained on. There's an assumption that the production data will be similar to what you trained on, and that may or may not be the case. So there's a variety of issues related to that. even things like evaluating how it's performing oftentimes can be very challenging. That is, you have to come up with a metric that defines when a model gives you a result back, how do you assess whether or not that was a good result or not? Or maybe that now means you need to update the model in some way to account for certain types of answers that are giving that are maybe incorrect or not accurate enough for what you're looking for. So there's this whole notion that, the types of answers that you'll get out of a machine learning system, they're not deterministic. They're not necessarily guaranteed to be what you think that they should be. Whereas in traditional software, you can pretty much, guarantee that for a given input, you can get the same kind of output. That may not always be the case with machine learning. So there's a bunch of those kind of factors that people coming into a machine learning project, they use their frame of reference of, okay, we're going to treat this like we have all of our other software projects, when in practice, it's actually quite a few differences like that.
So I totally agree with this, and I think it's a great insight. There is also another aspect to deploying machine learning projects into company, and that's kind of the human aspects. We often talk about that there is not enough talent, there are not enough data scientists, but in your book, there's a chapter where you talk about what the data scientists would like managers to know. And in my experience, I've seen that sometimes people hire data scientists, but not necessarily make them always happy. What are your insights in that area?
It's common for a data scientist that need to, tell a management team that not every business process or not every automation task is right for AI or machine learning. Now everybody wants to wield the machine learning hammer any chance they get, and they go around thinking everything is a nail. When in practice, that's not always the case. And in fact, we see a lot of examples where a company asks us to do a deep learning technique just so that they can say that they're using deep learning at their company. When really, deep learning is not maybe necessarily the best technique for that specific application. Oftentimes people jump to, hey, let's automate this process, when really you can only talk about that in terms of, do you have the data that's necessary to automate that process? So really it's a combination of, let's talk about the process, but then let's talk about what data we have that will be available so that we can automate it. Because there may be lots and lots of processes or things that you want to automate, but if you don't have the data necessary to train a model, in many cases, you're just not going to have a lot of success. I mentioned it a little bit earlier, and it's often challenging to figure out how to measure success with a machine learning model. Because again, typically how it works is you're going to send some data in and you're going to get some answer out. And then how do you measure whether the answer that came out was a good answer? And then while that maybe sound simplistic and rather straightforward, in practice, it turns out that that's not always easy. And it can be very complicated as how you determine whether or not you're successful or not. And so oftentimes a management team may look upon the data scientist to say, all right, tell me if the model is accurate. And the data scientists look at the manager and say, well, I don't know, you tell me, how do I measure to determine whether or not the model is accurate?
So we will often say that managers should understand that we need data to apply machine learning and so on. But there is, in my opinion, another element there, and that is there is an entire data process that is involved with these machine learning projects. And so it can be, the data preparation part, and then there is the part that has to do with, measuring the quality, which in the end, measuring the quality of the process, it comes down to selecting a bunch of data on which making some measurements. Have you found some general best practices around putting together data processes that you could share with, middle management audience?
Oftentimes what's necessary to give data to a data scientist, for example, to start, developing a model, they'll have to go through and create what's referred to as a data pipeline of sorts, where it's not generally the case that you do a simple extract from a single system and that's all the data that's necessary for a model to train on. Typically, you're pulling from multiple data sources. You may have to do some transformation on the data. And so what you need to go in thinking is that you actually have to build a pipeline that helps get data from its kind of raw form into a form that is going to be useful by a data scientist. And one of the keys to think about with this is that this isn't just a one-time activity, right? So imagine you need a data set to do some training on, but you have to keep thinking about, all right, imagine we're going to get this into production one day, because again, we're not doing science experiments, we're doing a project that we think is going to have business value. And so that means we need to be able to replicate whatever data wrangling we do in our development process, we need to be able to do that in our production process as well. So the process of building that data pipeline isn't a one-time thing. It's something that you initially build a development set on, but ultimately you need to be able to transfer that into your production environment once you're ready to deploy this.
What do you think, like in your experience, if you had like, and I think, very often managers look at things from a cost perspective. If you were to estimate the cost of handling the data, everything is to do with the data in a machine learning project, where would you put kind of the average? Is it the 10%, the 30% of the cost, the 40%?
The data preparation, or even just data wrangling, let's take out the fancy machine learning or any of that part of it. Just the simple act of trying to get the data into a format that can then be used by a data scientist for machine learning or something like that. It can be anywhere from 50 to 80% of the time spent on a project. Right, 50 to 80%. I mean, we're talking non-trivial amount of time. It's a big chunk of time. And again, it still kind of blows me away, all these years later, that we've not really been able to take that time down that much, right? If we could build a magic tool that would automatically get the data in the right format and syntax, we all want that, but no one's been able to build that yet. And part of it's just because every project tends to be a bit of a snowflake. It's the first time it's been done, or they have unique requirements. And so it's not easy to say, well, there's just some universal way to kind of get the data prepared. Oftentimes there's a fair amount of heuristics and craftsmanship that goes into getting a data set prepared.
Why don't we take a look at some of these projects that we've done and see what are the learnings? So I saw, for example, you have a project with emails, you have projects in healthcare and how to find diseases. Why you don't tell something a little bit about these projects and maybe have our audience kind of get a feeling of the type of work that you do?
Yeah, so we at Infinity ML, again, we have a sizable team of data scientists. We have over 10 PhDs that have specialized in machine learning, a rather large team of data scientists and machine learning engineers. And so our expertise span the spectrum of machine learning techniques. So we've done everything from image processing to text processing to biomarker discovery in the healthcare space. We've done a lot of interesting work on image processing. There's one where we're automatically detecting knives and guns and X-ray scanners. In general, we'd love to do more image work, but in the enterprise, it turns out there generally tends to be more text-based data. Right? Most enterprises don't have lots of images sitting around. They have way more text, documents, things of that nature, at their disposal. And so one of those large sources of text is email. And so one large retailer, Fortune 500 retailer, approached us where they have a team of over 60 people that are constantly going through their emails to try to determine if there are certain things that were done during a negotiation with the supplier that weren't captured in their contract system. And so again, they have 60 people that are just scouring these, literally millions of emails that are generated or that are created and trying to find these things. And so we built a system, a machine learning system that went through and automatically scanned emails to try to automatically identify where there are these potential, missing elements, where there a negotiation that occurred that wasn't captured in the contract system. And again, a lot of that goes back to trying to identify the way language is being used during negotiations. So that's one example of using email where we've had a lot of people trying to do it in a sort of repetitive fashion, and we can apply technology now, not necessarily to replace all 60 people doing that, but now to make it much easier, make those people much more effective at identifying across the hundreds of thousands, millions of emails that are being created every day, which ones are the right ones to look at.
Do you have any way to measure how effective your process is? Some measurements that show an improvement with respect to the status quo?
Absolutely. And there's another example, again, in the tech space, where we were analyzing legal documents. And this is for one of the largest legal services firms in the United States. They literally process thousands of legal documents. And one of the tasks that they have to do is they're given a dump of, call it 1,000 documents. And these are just raw PDFs. And the first thing they have to do is to sort them into certain types of documents. So here are MSAs, another group may be statement of works, another one may be, other types of agreements. And so what we did was built a classification system that could automatically sort the documents. And we were seeing in the low 90% accuracy levels for those. And so we went back through and thought, well, why are we only getting 90% accurate? Why can't we get 100% accurate? And typically with machine learning, you're not going to get 100% accuracy, but we thought it'd be an interesting activity to see what some of the errors were. And turns out some of the errors came back to problems with the human labeling that occurred on the data that we trained on. So if we traced it back and we thought, well, this document we mislabeled through our model, if we went back through and kind of, sort of done a retrospective on what led to that, turned out that we trained on data that was mislabeled that ultimately misinformed the model. And if we corrected that, now the accuracy level went up. And so it's kind of interesting that a lot of people view human labeling as sort of the ground truth, which it typically is, like we're assuming this is true. But in many of our cases, when we start to eke out that last 10% of performance, what we find is in many cases, those errors are due to errors in human labeling. And so what I would say is that there are, certain use cases where you can get significantly better than human level performance, especially when you're talking about this sort of mass. Imagine you have, a human or even a small team of humans having to automatically classify 1,000 documents. The chances that they're going to, accidentally miss one or mislabel one is pretty high, versus if you can get the model right, fatigue doesn't factor into a machine learning model, right? And so what we see is that you have to be careful. Just because something has been human labeled doesn't mean it's necessarily accurate.
The process that you're identifying and you're describing is a process that is not 100% accurate, but it competes with human fatigue. And also the human process is not accurate. So where is the point where the corporate or the management there feels comfortable to have the machine doing the job?
One of the examples I like to talk about is that just because we have humans doing a job today doesn't mean that it makes sense for humans to do that job. And so for maybe some of your older viewers, one of the sort of examples I show sometimes when I give a talk is from an I Love Lucy show. This is an old show back in the, I don't know, 40s, 50s maybe. And she's at the chocolate factory, and she's there inspecting chocolates as they come across the conveyor belt. Well, the conveyor belt starts speeding up, and she can't keep up, and she's popping these chocolates in her mouth. It's a pretty funny segment. But the point is, like, humans should not be doing that job, right? And there's a lot of examples like that where just because we have a person doing it doesn't mean that that was the best intended use of people time. It was just because there were no technology alternatives at the time. And so if you kind of look at it from that lens, that just because we have people doing it today doesn't mean that we should always have people doing it. There's likely better uses of people's time and talent than doing something that's highly repetitive, that can be, it will involve fatigue over time and all of these issues. If you look at it through that lens, even if you could just get at human level performance, in many cases, it makes sense to go ahead and move forward with trying to automate that task. Because again, you wouldn't want to have a person kind of doing this highly repetitive things. Then there's the issue of, just if you have people leave and now you have to retrain new people over time, if you're able to automate that task at near human level performance, it just makes sense to do that for the long-term savings.
Something that is extremely relevant in the enterprise world. There is an entire conversation going on. As I said, here in Silicon Valley, there are several companies trying to sort of developing technology for monitoring the quality of the algorithm, so that if you like, they can put a stamp on the algorithm and say it's enterprise proved, like this, you can trust it. This is kind of there is an entire market of having manager trusting. And that leads me to, some part of your work, of your recent work, is also touching the medical field, the things like diagnosis. This is, if you like, high stake type of work. It's a type of work where failure is less acceptable. Are we at the point where, we can trust the machine? And what are the situations where we can trust the machine over the human, or we need a collaboration between human and machine?
In almost all use cases that we've seen, it's rarely the case that, you build a model and then you immediately switch over to that model and humans are completely out, right? That just doesn't happen in practice. Typically there's a process, maybe even long-term, frankly, where you're going to have the, people and the models working together. And I think ultimately, again, in the near term, and that could be even for the next 10 plus years, that's going to present the best result than just having the human work independently or just having the model work independently. And so I rarely see it the case that, all right, now we've just turned over all thinking and logic processing over to a machine and humans out of the loop. It's almost always the case that, at least to begin with, we'll have a model that will provide information, much like the security X-ray scanning that I mentioned earlier, where we can help detect knives and guns. We're not just going to rely on the model to get every one of those right. It's more of a notification system to let the person, the security person, know that there may be a problem that they need to look at, right? And so it'll be these two working together, and it's the same way in the medical field. It's not the case that we're just going to say, all right, this is all turned over to an algorithm now, and we're all dependent on that algorithm being as accurate, more accurate than a human. We're actually going to say, all right, this is going to be information that now a human can use to make them more efficient.
Once more, we're talking about this human-machine collaboration, which is what's emerging. It's basically machines is assisting right now human beings. However, there is a lot of discussions out there in the society about a variety of topics, including the superintelligence and the Skynet takeover. I don't want to go all the way far away, but I think at the much more ground level, people are concerned about excessive automation in our society. We will not be able to compensate the job creation. So it's not like people don't understand the technological revolution brings some level of economic growth, but they're fearing that we're going too fast now and we're going to reduce jobs. I know that you have actually written an article on this, and the article is basically talking about the entrepreneur moral dilemma. Should they disrupt an industry with artificial intelligence? Can you tell us a little bit about your view on this topic?
Yeah, first and foremost, I think the disruption to the workforce has been overblown. It's hard for anyone to know for sure exactly what the impact's going to be, but what we know, at least right now, is look at the unemployment rate. Right, the unemployment rate's at a historic low. Again, not to say that that's exactly the best measure. You could say that the underemployment rate is ticking up or is higher. And who knows, 5 years from now what the unemployment rate will look like. I just know that since the machine learning boom started, which is roughly 2011 or 12, the unemployment rate's only gone down. Right, and so we have that as a data point at least to say that there may be significant disruption, but we've not seen it yet. Again, that's not to say it won't happen in the future, but I think in general, we've overstated the impact that this is going to have. I also think we've understated the impact that the opposite situation is going to have, and that is the number of jobs created because of automation. And so, for example, one of the things that we're seeing, or I'm seeing, is that it's likely the case that you're going to need a human in the loop to help with either coaching or assisting a machine learning model to get better over time. Those jobs don't exist today. Again, if you go back to what I was talking about earlier in the talk, where you need somebody that's evaluating and monitoring the results coming out of a model, that person is going to be there to then maybe provide feedback to the model as to how to improve. Again, that's not a role that's defined today. And so I think there's going to be a new class of jobs. Again, will that offset maybe some of the ones that go away? I'm not sure. The article that you referenced that I wrote about, let's just assume that you could automate a significant workforce. Should an entrepreneur still proceed with that business idea? And again, it's indeterminate right now as to whether that you could ever even know that ahead of time. Again, you could go with the full intent. I mean, probably the best example of it today is long haul trucking. Right, that's the probably favorite example that people like to cite, that those jobs are going to be automated thanks to autonomous truck driving in the future. The however many millions of truck drivers are going to be automated away, and there's not going to be jobs to replace them. Again, we don't know. We'll see what develops out of that. But even that, I would say full speed ahead on creating the technology. We don't know what the outcomes are going to be, and in many cases, the outcomes are likely going to be different than what we might think they would be, because there's all these other consequences, unintended consequences, maybe in some cases bad, but in some cases good as well, that we just can't predict. And again, if we look at history as a best example, we don't have a lot of negative examples, globally speaking. Now you could say that sure, manufacturing in small Midwestern towns took a hit and the town had a hard time, but in general, probably most people would say societally, socioeconomically, we've done better over time, right? And so again, it's not an easy topic and it's very nuanced, but I would say that in general, I'm in favor of us continuing down the rabbit hole when it comes to this technology progression, because we can't know that if I executed on an idea, that means I could wipe out a significant workforce.
So if we look at your business model today, basically your job is being created by this new technology and the demand that's out there for basically automation. There is a demand. So you've created this company. And if you think the reason why this company exists in a way is, one is the demand, but the other one is because the technology is not good enough to be fully automated. So you need people that, one, understand the business problem, two, that formulate the business into technical terms, and then you need all this data preparation, data pipeline thing that is really, I always stress it, it's really a big part of the entire equation. What technology do you expect in the future to come up that might, if you like, put yourself out of job? I'm just joking, but what do you think has to happen?
Oh, it's totally a fair question. And there's something already there that at least people talk about. It's called auto ML, or auto machine learning, where you essentially can create a process to automatically discover the right algorithm to use for a given problem. And what I would say is that, I would welcome that. Now, at least from my perspective, I think we are many, many years away from that actually being able to replace the type of data scientists we have. I think that technology is very immature. The problems are way more difficult than what those techniques can solve. But I would say that, is it out of the question that data scientists can be automated in 10 to 15 years? I don't think so. I mean, I think you'll still need, just like you need software developers today. Since I've been a software developer, there's always been people that think that we're going to be able to automate the software development process. And that's just never happened, and really not even come all that close. It'll be the same thing with data scientists. That's the new thing for people to say that we're going to automate. And not to say that we won't automate around the edges of it, but I just don't think anytime soon that you're going to be able to really automate a good data scientist.
It was a great honor to have you here. Very interesting interview. And for whoever is watching, if you have questions, please reach out to me and comment in the bottom. Or if you have suggestions for additional content, just reach out to me at Conversation Artificial Intelligence. And for the time being, Robbie, thank you so much. It was a great pleasure having you here.
Yep. Thank you for having me. I appreciate it.